Hi, Year 9. Here's today's work. We're looking at terminating and recurring decimals. So I want you to be able to know what the difference is between them, and we're going to also work some of them out from their fractions. So first of all, what's the difference between these two things? Well, a terminating decimal is one that stops. Okay, it's got some digits in it, and then that decimal just stops itself. A recurring decimal is one that repeats. Okay, it's got a repeating pattern in it, and the digits go on forever. Okay, so here's some examples. 0.461. That's a decimal that stops, so that's a terminating decimal. Okay, I'll put T for terminating. This one though, 0.325525, well that's got a recurring pattern in it, that's repeating, so it's recurring. Okay, and this is one way to write our recurring decimal with like a dot dot dot, but there is another way that we can do it by looking at the bit that repeats, which is the 2 and the 5. Okay, that's the repeating section that goes round and round. Another way to write this decimal is to put the bit that repeats. Okay, there's a repeating bit again, and then you put a dot on the first and last digit that repeats. So 0.325 with these dots, that's another way of writing this decimal down. Okay, this third decimal, 0.617617, well that repeats as well, that's a recurring decimal. And this time it's 3 digits that repeats. There, that's 617, that's a repeating chunk. If I want to write it with the dot notation like this, if I want to write it in this form, then you can put 0 point, put the repeating part down, and then the first digit gets a dot and the final digit gets a dot. Okay, you don't need the one in the middle. So that would be the way to write this one to show that it repeats between the 6 and the 7. Okay, so I'm going to show you how to go between the fraction and the decimal. In the final column, you're going to write down if it's recurring or terminating, and then I'm going to show you what to do with this column as well, because there's a little investigation involved with this column that I want you to have a think about. So starting with, I'm going to do 3 examples. I'm going to do an 8th, I'm going to do a 7th, and I'm going to do a 15th. All right, I'm going to do these 3. And then you're going to do the rest. So to do a fraction into a decimal, we've looked at this before. What you have to do is you have to divide the top number by the bottom number. Okay, you've got to divide the numerator by the denominator. If I want to do that, and I want to use a bus stop method to do that, I need to set it out like this. Okay, I need to do 8 into 1, because we're dividing 8 into 1, 1 divided by 8. I'm going to need some placeholder zeros because of all the decimal places that I'm going to get. Okay, so you set it up like this. 5 zeros should be enough for the easy ones. The further down you go, you might need some more zeros. Okay, so I've put just enough to help me out. Right, now to start to do this sum, I might need the 8 times table, because those numbers are going to help me work out what these digits are on the top here. So I'm going to do that first of all. So down here, somewhere on your page, let's put the 8 times table. And you need to go as far as 10 lots of your number. Okay, I'm going to go as far as 10 times 8. That's 8 lots, then that's 9 lots, and that's 10 lots. Okay, so with that in mind, I'm going to try and divide 8 into all of these numbers that I'm going to get. All right, so let's start this off. 8 into 1, well, I can't fit 8 into 1. That's going to be 0 8s. Okay, decimal place needs to line up with this spot here, so I'm going to copy the decimal place, and then my remainder is going to be 1. So I'm going to put 1 on the next digit along, so now I've got 10. Okay, now I'm dividing 8 into 10. Let's use our list. I've got 1 8 can go into 10, and then I'm going to have 2 left over, because 1 times 8 is 8, and I need to get to 10, so that's 2 left. Okay, next digit along, now it says 20, 8 into 20. From my list, I can fit 2 8s into 20, and 2 8s would make 16, and then I'm going to have 4 left over. So 4 goes on the next digit along. Okay, next digit along, 8 into 40. Well, that's an exact amount of 8s. That's 5 8s. So 5 is the final digit. There's nothing left over, so my decimal is terminating. Okay, it stops there, and that's the rest of my decimal. Okay, so I can write that in this box. The decimal version of an 8th is 0.125. I'm going to clear these decimal times tables away. It's a terminating decimal. It stops, so I'm going to put T for terminating. Okay. Then finally, for this column, what I want to look at as well as the decimal version, I want you to look at this denominator down here, okay, the number on the bottom of your fraction, and I want you to do a factor tree for it, okay, a factor tree that helps you work out the prime factors. So here's my 8, my denominator that I started with. I'm going to see if I can split that into smaller numbers using a factor tree so I can get the prime factors. So what can times together to make 8 that's smaller than 8? Well, I can do 2 lots of 4. Okay, 2 doesn't split any further than that. 2 is a prime, so I'm going to circle it as a prime number. But 4 can split into 2 times 2. Okay, we have done lots of these in previous lessons. Hopefully it should be familiar to you as to how these are worked out. Okay, so once you've got as far as you can, okay, these dead ends are my primes, and this is what makes up my 8. So in this box, you're going to put down 2 times 2 times 2. Okay, you could also put 2 cubed. I don't mind if you want to put it as a power. In fact, that's probably better things to do, but 2 times 2 times 2 is fine. So what I want to do, when you filled in these two columns, I want to look at a link between them. Okay, specifically, if you highlight all of the terminating ones, can you see a link between the terminating decimals and what's in this box over here? Okay, but first of all, I'm going to do a couple more examples so you know what to do. Let's do a seventh. Okay, seventh is this one. Let's do 7s into 1. Let's write down the 7 times table to help us out. Up to 10 lots. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. That's all I need for the 7 times table. Then 7s into 1. That goes no times. Copy the decimal place. There's 1 left over. 7s into 10 goes once to make 7, and there's 3 left over. 7s into 30, I can get to 28 with 4 lots. And then there's 2 left over. 7s into 20, okay, looking at this, that goes in twice, that makes 14. And then there's 6 left over, 6 is my remainder. 7s into 60, I can get as high as 56, that is 8 lots. Oh, that's not a very good 8, let's do that again. Okay, 8 lots makes 56, then there's 4 left over. 7s into 40, I can get to 35, that's 5 lots. And from 35, there's 5 left over. 7s into 50, that's 7 lots, because that makes 49, and then there's 1 left to get to 50. But now I've got to a 1, that 1 remainder is a repetition of this 1 remainder. So I know it's going to go around in a big circle again through these values again. So I can stop now because I've got the same remainder twice. So then I know it's going to be 142857 again. So my recurring decimal cycles around these digits here. 142857. All right, so let's write that in the box. 1/7 is 0.142857. This time it's a recurring decimal, so I'm going to put recurring in the box at the end. R for recurring. Okay. Then I also need a factor tree for my denominator. There's my denominator. Now 7 doesn't split into anything smaller. Okay, 7's already a prime, so it's already finished its factor tree. It's just 7 on its own, so I'm just going to put 7 on its own. Okay, yeah, it doesn't split into anything smaller. Okay, one more I'm going to do. I'm going to do 15. Just to see what happens when you've got a 2-digit example. So same again, 15 times table, write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lots. Okay, there's my 15 times table. We can do the same as before. If you get a 2-digit remainder, then you have to put 2 digits on your remainder space next to these zeros. Okay, I'll show you what happens when that happens. Okay, 15 into 0, that goes no times. Copy the decimal place. 1 left over. 15s into 10. 10's still too small. Okay, I can't fit 15 into 10, that's still another 0. But now to get to 10 from 0, there's 10 left over. So 10 goes as a remainder like this, okay? 2-digit remainder like that. Then it's 15 into 100. Let's look down my list. 1, 2, 3, 4, 5, 6 slots of 15 I can fit. And that makes 90. To get to 100 from 90, there's another 10 left over. So another remainder of 10. Now it's 15 into 100 again. Well, that's just going to be 6 again to make 90 again, remainder 10. 15 into 100, 6 times. And it's going to repeat like that. Okay, so another recurring decimal with 2-digit remainders, and it goes 0.0666666. Okay, I'm going to write that. Oh, I forgot my recurring dots on that last one. Make sure you do that, okay? If that 7th, that has repeating dots like that. When we do a 15th, it's going to have a dot as well. It goes 0.06, and recurring dot goes on the 6 because that's the bit that repeats. Okay, that one is recurring. And for the factor tree, for 15, I can split 15 into two smaller numbers. 15 is 3 times 5. And both of these are primes. They don't split any further, so they're my stoppers. So 15 is 3 times 5. Okay, so I want you to fill these in. Try and get at least as far as the 15th. Okay, try and fill in the rest of these rows. And then, again, all of the terminating ones, can you think about what the third column is doing? Okay, is there a pattern in the third column that tells me if my decimal is going to be terminating? Okay, if you need any extra help, please let me know. Make sure you're using some working out space to write all of these things down and to do all of your workings out. Again, send me an email if you need any help or a comment on Show My Homework, and I'll get back to you. Okay, best of luck today, Year 9. Thanks very much.